business. This series is brought to you by an ACER Access grant to Penn State, Ohio State, and Future Generations University of West Virginia. Also sponsored by the project is a maple syrup producer survey. If you're a producer in one of those 3 states I mentioned, you should have gotten a survey in the mail. Please fill it out and return it. It really helps to inform what production looks like in our areas, which is not very well informed at the moment, and can help our industry gain some attention. So I'll be plugging that at the end again. Fill out your surveys, guys. Tonight we have Aaron Wilson with us. He's an atmospheric research scientist at The Ohio State University, and he's here to talk to us about climate change impacts and risks to southern maple production. Feel free to use the chat box for questions or comments throughout the session, and I'll turn it over to you, Aaron.
Great, thank you so much. And good evening, everyone. Hopefully everyone is having a spectacular day and a great November here as we wind down this crazy year of 2020. So certainly this is an honor to be here tonight, and I really appreciate this opportunity. So yeah, you know, we're here to talk about weather and climate, and you know, as we get started, I think you'll find, hopefully I can fit everything into the time slot that I have here, but you know, this is part science, you know, so there'll be some scientific discussion here. Hopefully not too deep for an evening program, but hopefully you'll appreciate that as well. But also it'll be about a story, a little bit about weather, a lot about weather and climate, how they're related, how they're different, how we can view these two things. And then, you know, get down to the business and the heart of the matter, which is how climate change is impacting your expertise in your field and maple production across the United States, and in particular this region here of the southern extent of the growing area. So that's really what I hope to do. I hope that you will find some connections that hopefully I'll spur some questions that you have, or you know, make those connections, because ultimately, you know, as a climate scientist, that's what I'm trying to do. I'm trying to make the connections to help others see the connections out there with weather and climate, because I'm not a maple producer. That's not my expertise. But it takes all of us. It takes the whole community of different folks coming together to think about these threats and how we might build some resilience to what we're seeing out there. So again, thank you, and we'll go ahead and get started. So a little bit more about my background. I grew up in Miamisburg, Ohio. So Miamisburg, Ohio, for those that don't know, is a little bit south of Dayton, down in Southwest Ohio. When I was 3, we moved to Miami, Florida. And even at 3 years old, you're aware of what a tropical cyclone is, a hurricane or tropical storm. And we had a few brush by. We never had a direct impact. But my family, we'd go down to the beach and we'd watch the interaction between the waves and the atmosphere. And that was really what got me hooked on weather. You know, so I feel like I've been blessed to know what I've wanted to study most of my entire life. We moved back to Ohio in 1987, and of course in 1988, we had what was called, Time magazine called the Big Dry. This was the 1988 drought across much of the Midwest, the Ohio Valley, pretty steep, pretty difficult drought for a lot of folks. As a matter of fact, that was my retirement photo that you see there in the top center. I had enough of farming by age 9 because of the drought, and so I got out of the business, as it were. But no, all kidding aside, you know, I had some interest in agricultural science, and now I have this opportunity to really bridge the interest in ag science along with the weather and meteorology. Of course, in 1989, Hurricane Hugo approached the shores of Charleston, South Carolina here. This was John Hope. Some of you may remember John Hope. He was the hurricane specialist at the Weather Channel back when they started throwing meteorologists out in front of these storms. Maybe before it became a little bit as silly as it is today, but certainly, you know, well-respected meteorologists that were doing it then. And then, kind of to make a long story short, you know, I had did my undergrad undergrad and graduate degrees at Ohio State, and now I'm also part of the State Climate Office of Ohio. We do have a climate office, and we're basically engaged with providing data and information to the entire state of Ohio, but also regionally collaborate with states around us as well. So it's a great, great opportunity. So that's a little bit more about my background and where I come from. Now, today, obviously, we're talking about weather and climate, and this picture is an illustration of, just a snapshot of the weather, how we experience it, right? This is a shot from a Western Ohio county this past summer. Corn's growing, it feels warm, right? We see those puffy white clouds, pretty nice day out there. Now, as meteorologists, what we do is we take that experience, those things that we experience on a day-to-day basis, and through symbols and numbers and charts and maps, we analyze what's happening, and we display that on a map like this. Now, over time, you start to collect a large amount of data, and that data can then be organized into a way that you can interpret changes over a longer period of time. And data are just data, they just sit there. They're just numbers. And what it really ultimately takes then is interpretation and dissemination to the community to think about what that data means and how that's impacting our lives, individually or collectively. And I feel very lucky to be able to do all of these things, experience the weather, but then also translate them to maps, into data, and then ultimately present to folks like you, and hopefully make those connections with the changes that we're seeing out there. So these are just some opening ponderings, I've called it. And feel free at this point right now to just throw anything in the chat that you would like. But in your lifetime, have weather patterns changed? And what have you noticed? How do you know? If not, that's okay to also type that out into the chat if you wish. Or just think to yourself and maybe jot it down on a piece of paper if you have it. What have you experienced? The impact specifically on your trees or your maple syrup production, but also the soils, the water, your comfort level. What do you notice about things when you're tapping, or any of the experiences that you have? Feel free to type those in the chat. You can do that now or throughout the program. It's okay. But hopefully I'm driving home the point that I want to make this as personal as possible, as personal as it actually is, because it does affect every single one of us. And ultimately, when we get down to the level of what we do about it, it's obviously going to be how do we, maintain resilience with the things that we like to do. And in this case, the maple syrup production here. Okay. So just some things to think about as we move forward through the program. Now, I always start with weather and climate. Okay, so weather, we sort of take it for granted, and we take it for granted. It's fast-paced changes in the atmosphere. We've got really rapid changes in temperature, wind speed, moisture over very short distances. Okay, so over a longer period of time, it may be difficult to establish or understand what those patterns are unless we take a broader view. So as meteorologists, what we like to do is we zoom out and we do an exercise like this, which is look at a series of satellite images over the surface of the Earth for a period of a month or more. And you start to see swirls of clouds right across the bottom of your screen. That's the Southern Ocean. You see it here across the mid-latitudes where we live in the Northern Hemisphere, but they're not as fast as what you see down here. Maybe you see these pulses of bright white clouds, that's what we're looking at, moving in the opposite direction along the equator. So ultimately, all of these really rapid changes in temperature, wind speed, and moisture can be represented over time by these larger scale patterns. And these patterns are what we mean when we say weather patterns. We typically see weather move from west to east, unless we're into summertime, and somebody mentioned Hurricane Hugo making it up into this region. Absolutely correct. We get some of that tropical influence during the summertime. So all of these typical patterns establish what we expect to happen in terms of our temperature and our moisture. So climate is a little bit different. It's slower varying aspects, averages over longer periods of time. So I often ask folks if they want to, take a stab at what that picture is there in the bottom right. or yeah, the bottom right. And it's kind of difficult to think about because we're zoomed in. Okay, we're zoomed in, but I'm going to play another video, a short video for you here. And you're going to see, eventually we're going to zoom out and you're going to see a dog. We're walking our dog. So let's imagine we're walking our dog here, and that dog is with a dog walker on a leash. Now that dog is driven by some natural tendencies. We know how dogs behave. Fire hydrants, another animal, fast food wrapper, something like that. That dog could be moving in the opposite direction at any one time that we're walking, or the dog walker, but we still expect both to be here in just a minute. And we do that based on the dog walker, the path that we see outlined by the blue footprints. So even that dog is meandering back and forth and it's going all over the place in a seemingly chaotic fashion, they're still moving along together. And that path that the dog walker takes can describe the mean path of the dog. That's what we mean by, a long-term mean or statistics here. So we can think of the dog as our weather and the dog walker as the climate. So as that dog meanders back and forth and we get record highs during a cool season or record lows during a hot season, this is how this is possible, because the weather operates on a much different scale than the dog walker, right? So we see these variations, right? And certainly once the dog walker is up in the upper part of this figure, it's much more difficult for the dog to reach those bottom, right? And we'll talk a little bit about that as we move forward as well. So I like to talk about the power of weather because obviously, weather is often destructive, in a lot of different ways. And this is a perspective from Ohio here. And I know there's a lot of folks outside of Ohio. This is my hometown of Miamisburg, 1913 flood, devastating rains across much of the state. And a lot of action had to be taken after this to shore up our rivers and prevent that from happening. We have winter time extremes. I would consider most of Ohio hasn't seen a real blizzard since 1978, although we've had some heavier thunderstorms. But that's an extreme event, right, for our region. The derecho impacted a lot of us on the call here. Long-lived line of thunderstorms. Probably most of us never heard of a derecho before this event. Meteorologically, we had this term, but long-lived line of thunderstorms. A lot of devastation throughout this entire region, and of course, we see a lot of flash flooding now, tornado outbreaks. So this is really the power of weather. It has the ability to really do a lot of damage. And if we look at our billion-dollar weather disasters for 2020, for the nation, currently we're at 16. This ties both 2017 and also 2011 for the most on record. We've had $16 billion weather disasters. This goes back to 1980. And you can see in the top graph, they look a little bit different depending on where you are. Hurricanes along the coast, flooding in the Midwest and inland, severe storms, and then wildfires out west. And that's going to be important when we think about that personal face of our changing climate. But if we adjust all these equally, we are far surpassing the average over the 1980 to 2020 period in our several years over this past decade. And if you look at, for instance, Ohio, Pennsylvania, West Virginia, these are not water scarce regions, right? This isn't like California or parts of the Four Corners region that can be described as water scarce. These are water rich regions. And for instance, in Ohio, most of the natural disasters that have occurred between 2008 and 2017 were rain-related disasters because we are a water-rich area. So I could argue that a lot of our region, one of the main facets of our change is through water and changes in our water, which is also important. But for the context of today, we're also going to talk about the temperature changes and the details and how that also, has big impacts on the maple production. So let's do a little bit of both practical and really illustration of these differences between weather and climate. And I'm going to do that by just looking at 2020, just looking at this past year so far through yesterday, November 18th. What you see on the left is the average temperature and its departure from the long-term mean. Now, this mean is 1981 to 2010. That's currently the operational long-term mean that the National Weather Service used. And you can see across our area, Ohio, Kentucky, West Virginia, Pennsylvania, very warm conditions. We were generally 2 to 4, 2 to 5 degrees above average so far for the year. Through the end of October, this is the 9th warmest year on record so far for Ohio and West Virginia, and 5th warmest year on record through October for Pennsylvania. And those records going back to 1895. 1895 and to the present, we have a robust, a lot of confidence in our observing networks, and that's why we stopped this ranking with the NOAA here at 1895. As far as the precipitation goes, if you look at the right-hand side, quite variable across our region. You know, we had some dry areas across Northwest Ohio in particular, and of course, much of Pennsylvania, which has seen even some extreme drought conditions in some of the counties, especially North Central Pennsylvania this season. So you can see vast differences across the area, but a lot of wet conditions as well. You know, 5th wettest in West Virginia, but 57th driest in Pennsylvania. So quite a difference, but you know, from those neighboring states. So I'm going to take this. This is sort of a climate view because it's looking at an entire year, but it's still, what did the weather look like? And I'm going to pick on my friend Les here up in Geauga County, Ohio, and we're going to look at the weather summary for Chardon, Ohio here. Now, what you're looking at are the temperatures, the highs and the lows. The gray bar represents the high and the low, the top and the bottom. And what you'll see as we've moved through the season so far, this record warmth in winter. Winter for Ohio was the 5th warmest on record going back to 1895. And a lot of our region, Pennsylvania, Virginia, West Virginia, was quite warm. And then we got into April and May, and boy, if it didn't get cold, and Les could speak to that, but certainly we had a very chilly time of it in April and May here. So even though you saw that, you know, so far for the year, we're well above average, April and May were not above average. We were quite chilly during that time. And of course, this extreme warmth in November, we had a couple cities here in Ohio hit 80 degrees for the first time in November on record, with records going back to the, you know, these sites back to the early 1900s. So certainly some extreme warmth here. And we have seen a little bit of cooler conditions as well, but you know, last year it was 90s, 96 in October. This year we've got 80s in November. But this is the weather story. This is how we experience it. And then if we look at the rainfall, the 2020 summary for Chardon, and I could do this for a lot of state, you know, any point, any station throughout the region. But this is what the daily rainfall or precipitation, actually the daily precipitation looks like at this station. A lot of rainy days. But if you look at it, 6 events had rain totals of 1 inch to 1.5 inches, and 5 events over 1.5 inches. So in 11 days, this station has reported 34% of its annual precip in 11 days. And right now it's running close to 50 inches, which Chardon's about 48 inches a year. It gets a little bit extra during the winter compared to other areas of Ohio, for instance, because of the lake effect snow. But it's already, you know, above the annual mean, annual total. And again, 34% of that fell in just 11 days. And that's an important facet of what we're seeing lately. But again, we can break that down into some seasonal averages, and we can look at our winter time across the region, December through February here. Extreme warmth across West Virginia, Ohio, Pennsylvania, and the like, running anywhere from 4 to 6, 7 degrees above average. The top center, this is looking at the springtime, close to average, you know, slightly above average in some respects, but you know, an average season. And then certainly the summer was warm, especially where it was driest in Pennsylvania. I know Ohio had our 6th warmest July on record, which really kind of initiated drought conditions around this region. So, you know, we're breaking this down into different ways, you know, from a weather and a climate perspective. These are the seasonal precipitation differences. Again, you know, you got a spring that's really close to average. You got a summer that's drier than average. An average over 6 months or more, it's just going to be take these 2 seasons and divide by 2, right? So if you have a record warm month and a record cold month the next month, you take the average of those and it's going to be close to average. So climate statistics hide a lot of details, and those details, I would argue, are very important for folks like yourselves that are in the, with the maple production and elsewhere. But we still see drought, even though we're seeing wetter than average conditions, the fifth wettest on record in West Virginia. For instance, parts of West Virginia certainly saw abnormally dry to drought conditions, and parts of Ohio. So we distinguish meteorological drought, which is the lack of rainfall, from agricultural drought, which is soil moisture deficit, and then longer term hydrologic drought, right? But what we've noticed is that across our region, recent droughts are really distinguished from the past. If we think about our droughts in the 1930s, droughts in the 1950s, these were multi-seasonal droughts, and things have changed a bit since then. We see, these extreme precipitation events that break up intense dry periods as well. Warmer temperatures lead to increased evaporation from the soil. Droughts are drier, more intense, and then we get these flooding rains that kind of punctuate what's taking place as well. So just starting to connect the dots between the first section in here and how we go through. So I'm going to break for a second just to take a quick drink. But what I'd like you to do is, feel free to throw in the chat, how did the weather of 2020 impact the maple syrup industry? How were you impacted specifically by the winter of 2020, for instance, the fifth warmest on record here in Ohio and very warm across much of the states here. So I really appreciate all of the responses so far on thinking about things. And as I look at them, we see, a lot of things that are going to come up in the chat later on. But how did the weather of 2020 impact your industry? Yeah, so there's already a response about the short season due to warm temperatures. And feel free to keep chiming in there. I'm going to keep us rolling so we stay on time, but feel free to jot it down on the side, and we'll have plenty of time to talk about things at the end as well. I just want to provide you an opportunity to jot things down as you think about them, and feel free to use that chat function. So let's zoom out now and start with the global assessment, because what I want to do is I want to start us off really broad from a climate perspective and zoom us in with a little bit of climate science thrown in there as well, just to provide the scientific background or the scientific basis for what I'm showing you today. So this is a familiar graph that I showed earlier in the presentation on the left. And what this is the temperature, January to December, the annual temperature differences compared to the 20th century mean. This is an average temperature from 1901 to 2000. And then we just take the difference of each year average temperature and subtract that long-term mean. So you can see the late 1800s and early 1900s were quite cooler than much of the 20th century. And then since about the late 1970s, we've seen a big uptick, a big increase in those warmer than average, warmer than 20th century temperatures. Right, so it's been mostly warmer than the 20th century since about the late 1970s into 1980. Okay, now 2019 ranks as the second warmest on record since 1880. That's when we have a robust understanding of the global scale. 2020 is currently on pace for the second warmest. It's pretty close to the warmest year, which is 2016. And then 9 out of the top 10 warmest years have all occurred since 2005. And 5 of those, the 5 warmest years, have all occurred since 2015, and 2020 is not going to be much different. So I think it's pretty astounding that if you were born after February of 1985, since the Reagan administration, you've never experienced a cooler than average month for the planet. That's quite a long time to go before we've experienced a cooler than average month, 1985. Now, spatially, what does this look like? And that's what the animation in the upper right is showing you. This is looking at differences compared to average over a 5-year mean from the late 1800s to today. And once you start getting into the latter periods here, you see a lot more red on the map. Now, regionally, there could be warmer and cooler areas. And I still, all the time when I'm talking to folks in Ohio, the 1930s are still generally the warmest decades, certainly the warmest summers that we had on record during the drought bowl era. Much of the United States was warm during the 30s and early 40s. The 60s and 70s were a cooler period. So we know that there's some natural variability at play, and we're going to talk about that just a little bit. But temperatures do get warmer compared to average, and a lot across the Arctic as well, which we call Arctic amplification. Now, there are a few things that cause climates to change. One, incoming solar radiation. And the plot on the right is just showing you that since our temperatures have been going up relatively through much of the late 1990s into 2000s, the amount of solar radiation has been going down, relatively speaking. So it's not just a temperature or solar activity that's taking place. Earth's surface characteristics. If we have less vegetation and more built material, this is why cities retain a lot more heat. We talk about urban heat islands, right? So we know if we change the consistency of the land surface enough, we can make some larger scale changes. We'll come back to the composition of the atmosphere, but variations in Earth's orbit and plate tectonics. Those variations in Earth's orbit are quite important. We call these Milankovitch cycles, and they're important because they operate on really long time scales. So a few of them to note, we go around the sun more like a circle sometimes, and more like an oval, and we oscillate between those. That will vary the amount of radiation coming from the sun during the different seasons. The other one really critical at the bottom, changes in obliquity. That just means our tilt changes. You know, the Earth is tilted, but because it changes, if there's less tilt, then you get cooler summers because you have less solar radiation hitting the high latitudes, the polar regions, and ice is able to grow season after season. So if we take the natural variability into play, right now we should be heading into cooler conditions because we actually are heading into toward less tilt, so less solar radiation in our higher latitudes here. So that's how the natural variability is at play. Now, the composition of the atmosphere is very important here. We have important greenhouse gases. Water vapor and carbon dioxide are two biggest. We also have methane and we have nitrous oxide. Now, water vapor and carbon dioxide contribute to 60 degrees of Earth's current temperature. And I'll show you how in just a second. But without the water vapor and the carbon dioxide in our atmosphere at relative levels, then our atmosphere would be 60 degrees cooler than it is. So this is what allows life here on Earth. Now, we've studied the impacts of CO2 for a very long time, going back to the 1700s, understanding the greenhouse effect. Eunice Foote, she was an American scientist that really did a lot of experiments on the warming effects of sunlight on particular gases, all the way through the 18th century, 19th century. In 1958, a graduate student by the name of Charles Keeling out in Hawaii started measuring carbon dioxide concentrations. And he noticed over a period of time, there was an annual cycle, right? CO2 was highest in May. Of course, being in the Northern Hemisphere, we know that springtime, we start to leaf out in May, and then those trees start to draw in that CO2, which decreases to November. And then as the plant material starts to decay as well, then we start to do that once again, where CO2 is emitted into the atmosphere, or not drawn down, from the trees themselves. So there's a natural cycle. But he started measuring in 1958. We were at 310 parts per million. Today, we are at 418 parts per million. So we've increased about 108 parts per million over the last 60 years. And the reason why that's important is because on these natural cycles I talked about before, it takes thousands of years to increase 100 parts per million. And we know what the impact of CO2 is on our atmosphere. It warms our atmosphere. And as we warm, we also increase the amount of water vapor. And I'm kind of letting the cat out of the bag, but that's some of the stuff that we're going to talk about. Now, how does the atmosphere warm? Short wave radiation from the sun, visible light, comes down, gets absorbed by everything here at the surface and transforms into infrared light or long wave radiation. Greenhouse gases, they do not care about the visible light. The light goes through them. As that energy is transformed to long wave heat, infrared, and is emitted, those greenhouse gases absorb that energy. And when molecules absorb energy, their temperature goes up. The more of those molecules we have in the atmosphere, water vapor, carbon dioxide, and others, the less of that infrared radiation gets to escape to space, and the temperature warms. And it's really that simple from an atmospheric perspective. Those particles don't care about the shortwave radiation, the sunlight. It's the long wave radiation that they absolutely love. But if it's just temperature, that would just be one thing, right? And that would just be one variable. But temperature rises, increases in temperature set off a number of feedbacks. I work at the Bird Polar and Climate Research Center, and a lot of folks there study about glaciers and ice sheets and how they melt. And when that water melts on the land, it runs off into the ocean and contributes to sea level rise. Now, it's been quite a while since our area has seen any glaciers. It's certainly been even longer since we've seen any oceans, right? So ultimately, trying to make those connections is sometimes a little bit difficult in the Midwest and in parts of the Mid-Atlantic. Like, what are the impacts that we're seeing? We know our ocean heat content is increasing. We know our sea levels are going up. But here, what are we concerned about? The increase in our temperatures and some of the seasonal differences, and the increase in the water vapor, the amount of water in the atmosphere, and that's contributing directly to some of the changes that we're seeing across our region. Now, I do want to mention the loss of Arctic sea ice because it's going to play in one of my last two slides here today. But we know that we're losing the extent of the Arctic sea ice. It has a natural cycle where it's least in September, greatest in March, but we've seen this 13% per decade decrease in the amount of sea ice. Now, with less sea ice in the Arctic Ocean, when we get into October, November, December, we get the opportunity, especially into the wintertime, even January and February, where warm air can really surge up into the Arctic. That cold air has to be displaced somewhere, and it moves down over the continents. And we get this thing called warm Arctic cold continents phenomenon. And those will tie into affectionately known as the polar vortex events. And we'll talk about that and touch that at the end of today's presentation. But again, to kind of start driving us even closer to our region here, when we look at the regional climate impacts, and I already talked about this earlier with the billion-dollar weather disasters, it looks different depending on where you are in the country, right? If you're out west, you're worried about those heat waves, the wildfires, but that also brings up a good point to talk about natural resource management, because ultimately climate change is a threat multiplier. It makes what we do harder to do it. As stewards of our trees, as stewards of our water, as our soil, it makes taking care of those things in a managed way a little bit more difficult. So this can apply to whatever region. It's just going to look a little bit different. It could be hurricanes. You know, it's likely hurricanes across the coastal regions. Almost no beach or coastal area unimpacted by tropical system this year. In the Northwest, or in the Northeast and the Midwest, a lot of it has to do with the flooding, the extreme downpours that we're seeing as well. So if we look at the seasonal differences in warming for the US, this is what it looks like. A lot of our region has been warming. Most of the US has been warming over time, but it's greatest and most widespread, unfortunately, during winter, right? Unfortunately, from a maple production standpoint, winter is when we've seen the biggest changes, about twice as fast as the summertime changes. Again, because that water vapor in the atmosphere during the summer limits the daytime heating, keeps your daytime highs cooler, but at night, that water vapor in the atmosphere will actually trap more heat close to the surface and keep our overnight lows a little bit warmer. So if we look at our region here, and this is from the Great Lakes Integrated Sciences and Assessment, it's a little bit old, it's 1950 to 2012, we can see that our winter and our spring temperatures are have changed about twice as fast as our summer and fall temperature changes. Right, so there's seasonal differences which have different impacts. In the summer, it has different impacts on the growth of row crops and things like that. Could have impact on our trees as well, especially when we pair it with perhaps drought or drier droughts. But then those wintertime warmth conditions, as we'll talk about as we move through. I'm going to skip that one and go to the precipitation. And again, if we look across the country, we've seen a 4% increase in the annual precipitation since 1901 here in the US. Over much of Ohio, Pennsylvania, a little less over West Virginia, it's been closer to 5 to 15%, and really driven strongly by fall trends. And you're going to see that on the next slide, along with the increased intensity of those rainfall events. Now, there's a lot of regional differences when we look at our different seasonal trends of precipitation across the region. So if you're in Northern Ohio, for instance, winters are getting wetter. In Southern Ohio and much of West Virginia, winters have actually dried a little bit over this period of time, between 1 and 5, 1 and 6, 7%. You look at springtime, it's pretty much wet most of the region. And then also in fall, again, our fall trends are the strongest trends here in the bottom right. Parts of Ohio, I know we've seen 35% increase in fall precipitation, and that's the same for lots of Pennsylvania, New York, and the mid-Atlantic as well. So we see these changes in the mean seasonal precipitation. This is the snapshot of Ohio, but we can look across, again, the Midwest and New York and the Northeast. If we look at the number of extreme precipitation events where it's more than 2 inches per year, since about the mid-1990s, we've had a higher frequency of these strong, intense events. And in Ohio's record, if we go back to the 1900, there are 3 other peaks in the record, which were all major flood years for Ohio: 1913, 37, and 59. So the point of this graph is that flooding, we're never far from flooding. Even in the middle of these dry droughts, flooding in that water, this water-rich area is still troublesome. And when we combine those two, we're talking about a change in our hydrologic reality. And that's the big problems that we're causing big problems in a lot of regards across the Midwest and the Northeast as well. So just to kind of top this off here and think about from Ohio's perspective, and again, this is translates to the states that are on the call and around the region. It's been warm and it's been wet. 4 of the top 10 warmest and 6 of the top 10 wettest years in Ohio have all occurred since 2003, and 7 of the top 10 warmest since 1990. And that's a 126-year record. So quite a long record there to look at that. But again, a lot of those details matter. You know, it's not just because it's getting warmer or getting wetter, but how is that happening? And of course, we start thinking about our future, right? I mean, we have to think about our future. And so if we look at our future climate across the US here, again, our observed changes have been driven strongly by winter warming and warmer nighttime temperatures. Now, I always kid around. These are based on models, and I'm actually not kidding around when I say that all models are wrong. Some models are useful, okay? So models are imperfect tools, but they give us a snapshot of the future based on our current knowledge and what we expect in terms of what decisions are we going to make as humans. Now, forecasting the weather is difficult. Forecasting human behavior is nearly impossible, right? But we can come up with certain scenarios to think about how much of those greenhouse gases do we have. And right now, when we look across our region, our mid-century, mid-21st century change is about 3 to 5 degrees warmer on average across this region. By late century, we're closer to 4 to 8 degrees Fahrenheit above average. That ultimately will cause some issues, right? It's already, we're seeing these changes, and these changes in temperatures are likely to continue. Again, the changes in our rainfall driven by increased water vapor, higher humidity levels. But we expect these continued seasonal changes in atmospheric circulation where we get a wetter, cool season, fall, winter, and spring, but a drier summer. Right. And I know I get to do a lot of ag talks, with traditional row croppers and things like that. And some of you may do that as well. What do you want? You want a wet spring, a dry growing season, and a wet fall, right? That's perfect. No, that's exactly what we don't need. But this is the pattern. This is what we're seeing across much of our region here that we're talking about today. So just, some variables we can pull out. How many days do we spend above 90 degrees? These extended seasons into the fall, we're looking at an additional 20 to even 60 days where we have more 90-degree weather, right? Longer seasons. We see some 90s lingering into October and even November potentially as we head throughout this century. Overnight lows falling below 32, which is very important in the wintertime for a lot of things. 30 to 40 fewer nights, right, in our region here, where we're falling below freezing during the wintertime. We need those freeze-thaw cycles, right, to move that sap. And so this is a critical issue. Growing season length. We anticipate another, forget the statement there at the bottom, but another 20 to even 40 days longer growing season. That means shorter winters. Shorter winters are something that we've been seeing, and certainly that could cause havoc on the industry represented here today. And then we do expect a lot of precipitation here, mostly in those heavy rainfall events. So I like to do this because not because it intentionally ruffles people, but I think it's a good thought exercise. If we think about our climate, Ohio, West Virginia, Pennsylvania, this region, and where we're heading. So if we think about all of the things I've talked about, longer growing seasons, warmer temperatures, especially during winter and at night, higher humidity, more rainfall, more intense rainfall events, more autumn precip. This is what Ohio's climate looks like, and West Virginia, Pennsylvania, Kentucky are very similar. Ohio's moving toward a mid-Atlantic winter and an Arkansas summer. I pause there intentionally because a lot of times people do take a breath, right? Our climate is moving. One could argue we've moved from an Ohio type climate to a Southern Indiana climate since 2003. And we're on our way to the Missouri Valley and then down into Arkansas. And Pennsylvania and West Virginia are very similar, really a southward shift in that climate toward the Tennessee Valley for our region. That's what we're seeing, right? So traditionally, I get to talk about numerous challenges to different groups, from additional sustained heat stress on humans, on livestock, ultimately lower food productivity, reduced quality, increased weed pressure, unpredictable growing seasons, flood risks, you name it. There are a lot of obstacles, a lot of challenges that lie before us when it comes to the changes that we're seeing. So it really, I think, behooves us to think about the changes that we're seeing and how we can build some resilience. And that really gets me to the heart of today, which is, trying to make the connections now with the maple syrup production impacts and some of the things I'm sure that have already come to your mind and some of the things that you've already thrown up in the chat. And I thank Les today for providing me just some, visual cues of some of those types of events. March snowstorm, early budding, that can be really, really big problems for your industry, right? So through my own research, because again, sometimes when I reach out, this is the first time I've had the opportunity to talk to the maple syrup industry. I learned quite a bit through this experience of putting this presentation together, and kind of thinking about some of the key climate threats to maple syrup production. So some of these, through different resources online, and I've labeled a couple of these later, but availability of different trees to tap, thinking about suitable habitat, and I'll show you one study that I particularly enjoyed reading about sugar maple trees and their changes and ranges by 2100, thinking about overall tree health, something I hadn't thought about before, which was interesting, reduced snowpack during winter, leading to some dieback and reduced shoot growth. More frequent spring frost, those warmer temperatures, breaking bud earlier. We're going to talk about fall springs here in a second. Growth declines in mature trees because of those changes that we're seeing in that May to October timeframe. Different tapping season, starting earlier with shorter durations. I've heard Les and Gary Graham and others talk about these impacts and climate change effects on sap quality, sugar content, metabolic, chemicals of the sugar maple and such. So it was really fascinating, for me to read about some of these impacts and to study some of those impacts. So, looking at the impacts from increasing temperatures, we've seen a northwestward shift generally in our growing seasons. And along with that has come about a 9-day to 10-day decrease in our increase in our frost-free season length. And so I started looking at some of the local data that we have around our region, thinking about what we call these fall springs, where we get these periods of 70-degree weather that cause the buds and the bud break, shown on the picture 2 slides ago. And I started looking at Ohio, for instance, our February to March period. Since 2000, 4 of the top 10 warmest February and Marches have all occurred since 2000. And 2016 and 2017 being the relatively those that have occurred most recently. But this is the paper that I'm going to refer you to today. This is a forest and ecology management paper, and the link there that you can see for some folks that study up in northeast part of the U.S. And so they were looking specifically at some sugar maple changes, and I wanted to share that with you today. So really content, sap flow, but also volume and other things. And what they did is they looked at stands spanning a latitudinal range over 2 to 6 years to predict the role of climate variation. And I'll show you those stations that they used in just a minute. Happens not to be in Ohio or Pennsylvania or West Virginia, but we have some from Virginia and Indiana as well. But what they found is a sap collection advances by about 4.3 days for every 1 degree Celsius or 1.8 degrees Fahrenheit increase in March mean temperature. And one of the other things that I found interesting is that the sap sugar content, they actually attributed that change to a degree C or 1.8 degrees Fahrenheit as well. And that has to do obviously with the May to October mean temp during the growing season. So to kind of look at a couple of outcomes and results from their paper here, again, in the upper right are all the stations that they looked at from Quebec, New Hampshire, Massachusetts, couple, Central Virginia, and also here in Southwest Virginia and Indiana site. So over the observed period, which is 1950 to 2016, there was a clear trend of basically the midpoint of the tapping season occurring about 1 month earlier, already increased changes of about 8 days, to be honest, but over that 1950 to 2016 period. So you can see the far northern mid-April, mid-tapping, late February in the southern portion. But by the end of the 21st century, their results showed that even in the northern areas, mid-tapping season would be late March, according to those same climate outlooks that I showed you earlier. But in places like southwestern Virginia, for instance, mid-tapping season is mid-January by the end of the 21st century here. So I did see somebody in the chat got the link. Thanks, Kate. So what about the volume and the sugar changes? Okay, so again, I thought, we had some sites in here that it's close enough, Virginia, and of course right there in the Virginia, West Virginia border as well. But their bottom line is essentially sap collection will be negligible in the warmest sites, these southern sites, by the end of this century. And I think that's a bit disheartening, but it is, I think, a robust look at the changes that we're seeing. So again, you can see the sap sugar content and its decreases by the end of the 21st century, and also the total sap collected. So you'll notice that the sap collected actually increases for that far northern site there in Quebec, with total sap decreases for the remaining sites. And in fact, this graph showing virtually negligible amount of total sap by the end of the 21st century, at least from sugar maples, right? So if you look at the total syrup here, down for most sites, but up for that most northern site. So a clear trend toward lower, more variable sugar content by the end of the 21st century, some 28 to 36% lower across these sites. So kind of humbling, I think, from these results. And then they also looked at, part of the reason behind this, changes in range, sap and sugar, from a spatial standpoint. This is looking at the observations 1950 to 1999. Again, we're looking at the top graph here is the midpoint of sap collection for day of the year. That's what this number represents. Total, gravity sap here, sugar and total syrup here. And so you can see by 2090 to 2099, just this, midpoint is projected to be in March or later, in only half of the time or less across the southern 2/3 of the range. So this southern range, the midpoint is occurring much sooner. And you can see the change on the right if you want to take a little bit closer look at that. The southern half of the sugar maples range is really, where you see the largest changes, 30 to 40 less sap per year projected to be collected on average. And so this optimal production area right here, this darkest green area, is shifting well to the north by the end of the 21st century, based on these 14 models that they used and using those criterion that they outlined on that first slide that I showed you. So I think, ultimately for our area here across the southern region, it's a little bit humbling. And what I wanted to do is I took those calculations and I just did some quick calculations on my own for Ohio, West Virginia, and Pennsylvania, and then also included a 5-year running mean. So this is that mean March temperature that they talked about. And you can see Ohio in blue, West Virginia in orange, and Pennsylvania in gray. And we've seen an increase in that mean March temperature. Now, the black line is a 5-year running mean. So it's looking at chunks, basically every 5 years and then advancing forward in a year. But if you look at that change, it's generally, for mean March temperature here in Ohio, it's been about 3.78 degrees Fahrenheit, which per degree C means that it's a 9-day earlier season in terms of that midpoint tapping time period for this southern extent, this southern region. And recall they looked at the sugar, right? The sugar content over this time period as well. And that really being the previous May through October mean temperature. And that's what I'm showing on the right. Again, for these 3 states that I picked out in the Ohio 5-year running mean, it's been about 1 degree C change in that May to October. Again, our strongest changes have been in the wintertime. So the warmer season, we've seen less of a warming trend, but that still leads a decrease in the overall sugar content and the sugar quality. So, this is something that I took away as I started looking at some of these calculations. The one other thing that I'd like to mention too is, I started looking before I read this paper on February trends, and February warming trends are here as well. And this is looking at the entire 126-year record. But you'll notice, over the last 30, 40 years, this really big variation, right? What we call interannual variation between seasons of our temperature. And as a matter of fact, if you look at what we call standard deviation in a running sense, we had a pretty high year-to-year difference back in the early 80s as well. But we've seen a pretty big increase in that. Basically the waviness, the temperatures one season might be okay for production, whereas the next season they're simply too warm, too early to have a good season. And so we see that variability, not just in the year to year, but also even the day to day. We see large variability in those temperatures, which tie back to those fall springs and other things that I mentioned before. So as I start to wrap up, because I certainly want to leave plenty of time for conversations and discussions, and I think I'm over a little bit already, but what we draw is it's not just about what we're facing, but what can we do about it, right? Because we know that climate change is happening. We know that the scientific evidence is overwhelming in terms of what we see, but I'm an optimist, and I think there's something that we can do about it, but it really comes down to each individual community. Of course, this comes in many forms. We mitigate or stop this change through reducing of those greenhouse gas emissions. We adapt, so we change our infrastructure, our management plans, behaviors, and adaptation can be costly, right? And you can tell me and you can talk about the ways that you've had to adapt already. But ultimately, we may face consequences of failing to mitigate and adapt, and certain populations and certain things that we do become something they basically that we can no longer do, or we drastically have to change how we do them. So reading, again, learning just as much as you a little bit about the at least the climate resilience strategies, and I'm hoping you can provide me some feedback on what you're experiencing and some of the things that you're thinking about, if you are, in terms of changing production and changing strategies. But some of the things that I picked up on in terms of diversifying species, including, not just relying just obviously on sugar maples, and many of you use a variety of species. And of course, diversification is something that's a theme throughout all of agriculture, really, trying to diversify and build resilience to these changes we're seeing. Technology changes, different processing technology and vacuum tubing and things like that. Changing the markets. I don't think the maple market, the demand is strong from what I can tell. By the way, my wife says she really thanks you. She absolutely loved maple syrup. She wanted me to make sure I told you that tonight. But how can we also limit other environmental stressors? Because it's just not one area that we're getting hit, but what about pests and disease increases and those effects? How can we limit the polluted rain, the acid rain, which we of course have pulled back that since the 80s and 90s as well. But just increasing stands, that has the ability to increase carbon sequestration, to draw down those CO2 from the atmosphere. And so these are all different strategies, and I'm hoping that you can provide some feedback and reflection on that as well as we open up the discussion period here in just a second. All right, so I promise I will leave time, but I wanted to wrap up with what I'm labeling as a practical seasonal weather indicators. Again, I told you I was going to hit a lot of things from stories to weather and climate, but also I want to leave you with some tools or some thoughts, and also to think about 2021 that's upcoming here. So, one of the big seasonal prediction tools that we've relied on in the past is what we call El Nino Southern Oscillation, or ENSO. So during an El Nino, or also a La Nina, tropical Pacific Ocean temperatures, sea surface temperatures, they warm during an El Nino, or they cool during a La Nina relative to average. And this really impacts the patterns of tropical rainfall in the tropics, but it also impacts weather patterns across the globe, most notably in the US across the Ohio Valley in the Northeast during our wintertime. This is when we have the big changes in terms of El Nino. So when we have El Nino conditions, typically our region is warmer than average and drier than average. The subtropical jet stream is very strong. It stays wet across the Gulf Coast. That's typical of El Nino conditions. During La Nina conditions, we get a highly variable polar jet stream that leads to highly variable weather across our region here of the Ohio Valley in the Northeast. We see typically slightly warmer than average conditions overall, because we do get warm air intrusions from the south, but it tends to be very wet, especially as we turn the first of the year. We get into January, February, and March. An active jet often brings a lot of rainfall or snowfall. It can be both. But highly variable jet with big fluctuations in our temperature. And right now, we are currently in a La Nina state, and our models and all signs point to a strong to moderate La Nina season this upcoming winter. So what does that mean for us? Now, we can look at both the trends that we've seen over time, which have tended to be warmer, but also what we typically experience during our La Nina conditions. And so what I've done is pulled a few what we call composites from these different seasons, or these different variables here. So temperature is in the bottom left. This is the composite and trend. So again, it tends to be warmer across our region, but highly variable. So we still have the opportunity to see Arctic outbreaks, and we'll get to those in just a second, but we're likely to see a Gulf of Mexico influence as well. And honestly, that can provide opportunities where we see heavier snowfall. And as in fact, if you look at the right-hand side, this is what it typically looks like during La Nina conditions in terms of snow. It tends to be snowier in the Ohio Valley, less snow, a little bit less snow in the mid-Atlantic, certainly over Pennsylvania and parts of Virginia and West Virginia. But the rainfall, the total precipitation, it's a very wet signal. So again, La Nina conditions, and we're even more confident when we have stronger La Nina events like this upcoming season, that we're likely to be very wet, especially as we get into January, February, and March. Okay, so that's really what we're talking about. We're talking about highly variable, cold, but also warm with plenty of opportunities for precipitation. So when you're trying to make some decisions in season, I really suggest relying on the Climate Prediction Center. Many of you probably already do, but if you don't, this is the link there at the bottom where you can get snapshots. This is 8 to 14 day outlook currently. We're likely to see warmer than average temperatures now as we head through the first couple of days of December, with drier conditions as well to end November into December. The seasonal outlooks are important. So this is the December, January, February. It looks a lot like a La Nina pattern where we're kind of on the cusp of warmer than average conditions, but but a lot of our region will likely see warmer than average conditions and wetter than average conditions as well. So this is a very La Nina signal here in our climate outlook. So that's a page that I think is worth visiting. Now I want to close on these affectionately known polar vortex events. What's going on, right? Why do we, this is something that's been in our vernacular, I think, widely since about 2010. But what happens is there are some years where that jet stream across the Arctic is very strong. It keeps all of the cold air contained up across the pole, and we don't get a lot of intrusions of cold air. This is what happened last year. The what we call the Arctic Oscillation, which is the phase of this Arctic Oscillation is when it's strongly positive, it keeps all the cold air bottled up in the pole. When it's negative, when it's weak, that allows cold air to move south, especially as warmer air moves to the north. And that's when we get a lot of these cold air outbreaks that can get, quite chilly and quite cold across the region. So even though, for instance, last winter was warmer than average, we had a couple of cold periods. The winter before was warmer than average, and we had what I would call, one of these polar vortex events. Even though the winter overall was warmer than average. So one of the things that you can do, I thought I put, the link is in the upper right, and I'll make a copy of these slides available too, is to look at the Arctic Oscillation. Now, unlike ENSO, it doesn't operate on a longer time scale. Generally, it can change phase within a matter of about 10 days or so. What you're looking at on the right-hand side is basically today's forecast out to the 27th of November. And we're looking at upper parts of the atmosphere, up into the stratosphere, in fact, where this strong polar jet stream resides. And what it's showing you is we're ending the month of November on a very positive Arctic Oscillation, right? All of that cold air is really bottled up there in the Arctic right now. And I think as we head into the first part of December, we're likely to stay in that positive phase. And again, we typically do about a 10-day forecast on these because we don't really have trust or reliability beyond that. But you can see that we're likely to remain positive. So even heading into December, I still think, our temperatures are going to be running above average. And of course, that could still be a little bit cooler as we get into December, but certainly warmer than average is likely as we head into the start of winter here. So to kind of sum everything up today, I know it was quite a long journey over quite a few topics, but I hope you take home the fact that climate change is real and it's personal, right? It's personal because it's impacting you, and we together and individually have to decide how we respond. We know that our conditions are warming, again, especially at winter and at night, and becoming more variable. We know precipitation is increasing, especially in our fall to spring, with events becoming more intense. And of course, these have impacts then on tree range and health and volume of sap and sugar content. And the big question is how do we adapt? What does the future hold for the industry? What does the future hold for this area, this region? And I'd be certainly interested to hear conversation about that. And then more practically speaking, La Nina conditions likely mean this winter will be a little bit warmer than average, highly variable, with a wetter than average 2021 winter season. So with that, I'll go ahead and close today. You can always find some more information you can reach out at wilson.1010@osu.edu. And this is my contact information. And again, with climate change being personal, I've got two young girls that I think about a lot and their impacts as conditions continue to change. So I've talked long enough. Now it's time for me to listen, and I'll turn it back to Kate. Thank you.
Hi, folks. Thank you, Aaron. That was amazing. If y'all have questions, go ahead and start putting them in the chat. We can definitely take some questions. We also understand if anybody has to cut out for the night, but I'm sure there are probably some questions out there.
Yeah, or raise their hand. And
Yeah.
Make you speaker.
Mm-hmm. Oh my.
So there's a lot of impacts. You've put a lot of impacts, and I think some of those that we talked about, less consistent snowpack, more thaws in the wintertime, especially with those highly variable conditions out there. Yeah, I mean, it was a lot of what I expected in terms of what you're experiencing: shorter seasons, warmer temperatures, more extremes, wetter seasons or drier seasons, right? So that hydrologic, what we call it an altered hydrologic reality. So there's a question here that, wondering if you can comment on the relationship between fall springs and warming spring temps and indicators of the season like spring like peepers. Yeah, or perhaps producers have experiences or comments about this to share. Yeah, so these fall springs, and I'm assuming spring peepers, you're talking about actual spring peepers, right? Um, so the yeah, so certainly the spring warmth is kind of an interesting thing to think about, because again, with wetter conditions, one thing about spring with wetter conditions is that soil takes a little bit longer to warm up, and often we see those colder temperatures in April and May because that soil takes a long time to warm up. But that's really, it has a lot to do with the difference between daytime highs and daytime and overnight lows. So again, we're seeing a lot of those spring lows that are much warmer than average versus the spring high temperatures. And so that, obviously, not being a frog expert, but I certainly think that what I've noted from others are earlier experiences with spring peepers, earlier season, hearing them earlier in the season as well. And I saw a comment earlier about birds. I think, the natural world is such a interesting place to watch and to notice the changes that are taking place. The animals, the birds, the trees, I think are showing plenty of signs of the types of things that we're seeing out there. Kate, would you rather read the questions? I didn't mean to come in and kind of take over, but.
Oh, no, if you're comfortable doing it, go for it.
Yeah, so there was a question here that I can't answer, and maybe someone else on the call can, but do red maples do better than sugar maples with a warming climate? I mean, from my limited knowledge, obviously not having a maple background, I'm not sure. If there's somebody that can speak to that, please feel free. If not, John, I certainly don't like leaving answers on the table or questions on the table, and I would be certainly like to get back with you on that.
I don't know if the mic's on or not, but I'll take a stab at that one.
Thanks, Les.
We're seeing in areas that are more moderate temperatures, red maples taking over, and they're becoming a predominant tree in southeastern Ohio, moving out, actually taking over the range of the oaks. And so I would put that toward the fact that we're looking at wetter conditions. Everything else, reds do better where they're not in that particular. They do better in a wetter climate. Basically, sugar maples like to be up on the hill. They like to have dry feet, and they do real well in more, I would say, northern climates. And you'll see that in West Virginia, because in my experience, that limited experience in West Virginia, 2,500 feet, you start picking up a lot of sugar maples. Below that, you probably have a lot of red maples. And that pretty well draws a line. It gets quite dramatic down there. You folks from West Virginia, you want to add anything to that? That's where I'd be on it.
Les, I appreciate that. And also, one thing I didn't mention, and I meant to, is that elevation change. So generally, what we've seen, warming taking place, certainly at much higher elevations. We're talking tens of thousands of feet in other areas of the globe. But we've watched those tree lines also shift. That growth shift farther and farther up in elevation as well as those temperatures have warmed.
It's very dramatic down in West Virginia. It really is. It's amazing. I couldn't believe what I was seeing when I got down to Dry Fork where that picture was taken. That's at about 3,000 feet, depending on where they're at, could be closer to 4,000 if it's the top. And that was amazing. I mean, to see the growth of the sugar maples and how well they were doing down there. I kind of thought you didn't see that kind of range that far south, but
Yeah.
it's a different world. It's more of a climate like New England than it is actually West Virginia. Kate spent a lot of time down there.
Yeah, that's true. We had a comment saying that there are a good bit of sugar maples in West Virginia, and that's very true. West Virginian sugar makers often tap a mixture of reds and sugars. One note is that red maples do tend to bud out earlier than sugar maples do, which might be affected with warming springs. That's a little above my expertise level, but
Yeah, that could be a problem.
happening. We had a question of how do warmer temperatures affect the healing of spile holes? If Les, you feel like tackling that, or
The warmer temperature, what was the question again?
how does warmer temperatures affect the healing of tap holes?
They seal up. They have a tendency to seal a lot faster because what it does is it brings in the bacterial growth. The minute sap coming from a maple tree is sterile. I mean, when it comes out of a maple tree, there's no bacteria in it. It's coming through a sterile system. Once it hits the edge of the tap hole where air gets in, all of a sudden you end up with bacteria. You've created what we call a triangle where you've got the air, you've got the warmth, and you've got actually four things. It's more than a triangle. It would be air, and you've got bacteria, and you've also got moisture, and that's what it takes to grow bacteria, and that'll happen rather quickly. If it warms up, you should accelerate that growth, and that growth is exactly what it needs to heal those holes up. And it's sort of like cutting your hand. You usually get the air to it, and blood coagulates, and it'll heal up. And so you can accelerate that process. Our job is to try to figure a way of holding that back and keeping that hole sealed up so it looks more natural, and that's what we do with tubing. That's a discussion for another day.
Yeah.
So I saw a comment. Oh, go ahead.
Oh, no, I was going to pose my own question, but go ahead
Sure.
with the comment. I was going to say this is a little less sciencey, but do you have a favorite weather site that you go to for your weather tracking? I know maple producers across the world track weather very, very closely. So I was wondering if you had a favorite.
Yeah, so it's always interesting because, most of the time, obviously in digital age, we have access to a lot of digital apps. But you have to be really careful about the conditions that you're seeing because your closest location could be far enough away that it's not very accurate for your location. And so I use so many for different things. There are different things I like about different products. A lot of what I do is, I do forecasts on a daily basis myself. And so I'm looking at a lot of the forecast model data on a daily basis. So I would say I'm usually my number one source or number one go-to. But no, the National Weather Service is a trusted voice, is a trusted outlet for a lot of the products. And so that I use radar scope for the radar. If those have radar scope is a fantastic. And I know once you get into parts of West Virginia, radar always becomes an issue because of shadow and things like that as well. But I would say, the National Weather Service is pretty much what I stick to. But I look at the others. Occasionally I'll look at AccuWeather's 45-day forecast just for the same reason I would read the Farmer's Almanac. I love the Farmer's Almanac. Like I read it. It's interesting to read, but it's it's everything has its place, right? Everything has its niche, and certainly when I was a kid, I mean, I stuck to the Farmer's Almanac to a T most of the time. But so that's generally what I do. National Weather Service would be number one, and then all the others are kind of number two.
I love your thing.
All right, folks. Well, I still have you here. Feel free to keep asking questions. We have a hand raised. I will find that
Okay.
here shortly and give them. Oh, there we
it's
go.
Mark.
But I'm also going to launch a poll for y'all to take quickly before too many folks hop off for the evening.
Hey, Aaron, can you hear me?
Yes. Yep.
Hey, this is Mark Isselhart with UVM Extension. Thanks for a great presentation.
Awesome. Thank you.
It's a really interesting topic. You know, it's so complicated, and especially with sugaring where the season is so short and so reliant on really fine differences in temperature. You know, it's almost hard to comprehend, you know, going from the global scale down to the micro scale of like an individual sugar bush. But one thing that we've noticed, and it's so easy to fall into your own neighborhood and climate. So, you know, I'm definitely coming from a perspective of, you know, Northern Vermont. And I know this discussion was about Southern states, but the last major event that we saw with weather during the season that impacted a wide swath of production was 2012.
Wow.
And there was about 5 days for us in the 70s, which was extremely high. I'm sure it was higher in warmer areas. But we saw a really big impact on yield across many, many areas. And I wonder, you know, modeling is so flawed, but, you know, to me, I'd love to know what is there out there for predicting those kind of signals of, because almost to Les's point about closing up the tap hole, you know, it seems like there's a threshold where you get to a temperature and microbial activity really takes off exponentially and the vessels close up and you either lose quality of sap or the vessels are just plugged. Is there anything, even in the short term? I mean, I'm a little nervous about predicting out to 2100, especially with a relatively small data set in the paper that you cited. But
Right.
what do you think about trying to predict those extreme temperature events?
Yeah, so there are some mechanisms at play when those extremes happen. So for instance, March of 2012 was what we call a blocking. Part of it was a blocking event. We had, and by that what I mean is you get into a stuck weather pattern. It's usually dominated by very strong high pressure. It was almost like a midsummer scenario where we had southerly winds. And I know here in central Ohio, we hit 85 2 or 3 days there in March. So, I mean, it's, yes. Let me start with my first thing is typically during trying to predict weather in Ohio, in the United States, even 10 days out, as a lot of meteorologists try to do, is a very difficult challenge. And the reason I say that is because like today, you know, we're forecasting a system to move into the region, say on next Tuesday or Wednesday. That system right now is sitting somewhere out in the middle of the Pacific Ocean, right? So in 5 days, it's going to travel, or 6 days, it's going to travel here. And we all know about the butterfly effect. And we all know the things that happen in between that models are sometimes not good at picking up, or some subtle changes in one area of the world, and it changes the jet stream a little bit, and that has big changes here. So trying to predict out 10 days is very difficult, except for a few periods of time. One of those being, I think, when we see blocking events setting up. And when those start to set up, the models have improved. Our short-term weather models have improved to where they show us scenarios where, hey, you know, it's really looking like a persistent, certain for March case, like you're mentioning, a persistent threat of seeing dry, warm conditions, abnormally warm conditions But extremes by their very nature, models don't predict extremes. They're not designed to predict extremes. They're designed and ultimately, okay, oh my brain's racing because there's all different ways of answering this question. But models aren't a forecast. It's up to what the forecasters, how they're interpreting that data. So part of it, I would say, is recognition on forecasters to understand the patterns that are evolving in the models. That's the first thing. Second is our models have improved, higher resolution. Forecasts today at 5 or 6 days are as good as the 3-day were in the past. We can do that now out to about 6 days, and 10 days are what we used to do in 5 days. So there is improvement there. But to find a single source to be able to predict something like March 2020, I just don't think we have it. We don't have it right now, other than some of the information that's going into the Climate Prediction Center's 8 to 14 day or the 3 to 4 week outlook now. So there's been a lot of capital investment at the National Centers for Environmental Prediction on that 3 to 4 day period, because ultimately we do short term very well. We can do seasonal pretty well. It's that 10-day to 2-month period that's very difficult in the largest challenge. So I wish I had a better answer. This sounds so wishy-washy what I've provided you today, but ultimately we just don't have a single kind of a single bullet, that silver bullet that would help us with that. I think it's relying on really great, talented meteorologists and forecasters, and pretty much every National Weather Service has some folks here and there that are really good at that, or other forecasters throughout the country. But I just don't have a better answer for you than that.
Yeah, no, I totally understand. I guess, maybe not prediction, but, is there a sense that those sort of blocking events that led to 2012 are going to be more common? I know we've talked a lot about
Yes.
flashy
Now,
and more erratic weather, but is there a reason to believe that sort of event might be more common?
now that we do have some evidence. I would say it's a hotly contested area of debate in the scientific community right now. Along with these polar vortex events, we talk about the reason they happen is we get a stretch in the jet stream, what we call a meridional stretch, so that it becomes more amplified. So the peak goes farther in the Arctic and the trough comes down farther across the south. And in doing so, we slow down the movement of weather systems from west to east. This all ties back to the Arctic is warming faster than the mid-latitudes, and because that temperature difference between those two latitudinal belts decreases, that means that those zonal winds, or the westerly winds, which cause that westerly pattern, also weaken. And so when you get areas of high pressure that can establish themselves, they don't move out as fast, and that leads to day after day of what we call subsidence or sinking motion, and then warmth. And in something like March, that's why we see more 2-day or 3-day rainfall events, because the storms can move slower. These large synoptic scale storms move much slower, so they dump heavy rain over a longer period of time. So that we do have evidence that we're seeing slower westerly winds leading to slower progression of highs and lows across the United States. So from that, I would take the opportunities for seeing March 2012s are higher in the future than we've had in the past.
All right, thank you.
Yep. Just reading through the chat to see if there was any other questions. So there was a question here, and Les, maybe, if we know the nighttime temperature, daytime temperature swing is a false indicator of the beginning of sap season.
Well, that was one that I questioned that I had for you was, a lot of times when you're making that decision to tap, when do you know whether this is really the real thing or not? I guess that's what it comes down to.
Sure.
Because a lot of guys have gone ahead and tapped, and then all of a sudden they've gotten locked up I can see now with that polar vortex, if you got an accuracy over 60 days, you might have a feel for what's going on. What do you think, Aaron? Do you think there's,
Well,
what would, that's a tricky question.
unfortunately, yeah. So unfortunately, your season falls within a time where those large swings in temperature are obviously, I mean, that's part of what drives what you're doing, but then also you're susceptible to those polar vortex. Really, they get active late January into February and first part of March, typically. And again, predicting those can be very difficult. I think just wish, I mean, it's a challenge. I mean, one thing, and Les, you and I've talked, and Gary Graham and I've talked, and it's a really challenge because I think we know some general things about winter warming. We know it's highly variable. So we know, for instance, in a case like La Nina this year, you really need to be careful when you start, because I think, the opportunity to freeze up and get really cold again and things like that, and not have those frost, thaw freeze cycles is possible, right? In a highly variable year like La Nina.
So if I'm reading it right, you've got the main driver, which is the La Nina.
Mm-hmm.
That's the one that's moving the systems across the United States. That's the main driver.
That is yes.
The fly in the ointment, so to speak, is the polar vortex sitting up there.
Yep.
That if something happens that triggers that to come south, you're going to lock up.
Yeah,
and it could lock you up.
Yep. And so relying on that Arctic oscillation forecast and just thinking about, okay, if it's forecasted to be positive for the next 10 days, then it's not likely we'll see any big cold air. Versus, but we can't get better than 10 days on that, because the scale, it's the dog that I referred to earlier in the talk. It's the natural variability that's somewhat chaotic. We can forecast it to a bit, and kind of our horizon on that, it's about a 10-day lead. But that's it. That's all we really have.
That's not going to help much. 10 days.
Right.
Big tap. Maybe there's some value in not tapping everything at once. I don't know.
So Aaron, we had one last question. Are you actually sitting in the snowy woods?
No, actually, I'm not. So the story behind this is I don't have virtual backgrounds, and of course, most of everything has been virtual for the last 9 months. So my wife bought me a series of different weather tapestries, and I haven't used this one yet. And I thought this crowd would be the perfect one to use this winter snowy background today. So I appreciate the opportunity. So these are actual tapestries. It's not a virtual background. I just wish I was there. So like most meteorologists, we love snow. I could argue that's why a lot of on-camera meteorologists hype snowstorms too much. But we certainly, I'm not as lucky as Les. I don't live in the Lake Erie snow belt, which hasn't been much of a snow belt in the last year and a half. But
no.
Certainly, I wish we get a little bit more down here. So that's what I'm hoping for this La Nina season. But anyway,
well, we'll take what we get, I guess.
That's right.
And one more thing, Les, do you want to give a plug for your producer survey? And we can close
Oh,
out.
yes. The producer survey is out. The 2 editions have gone out now. We've been polled twice for the producers out there across West Virginia, Ohio, and Pennsylvania. And I think we've got about a 35% return as of today on the producer survey. We'd like to do a little bit better than that. That's in Ohio. I think it's 39% in West Virginia. So I would say that I would encourage every producer that got one of our envelopes from Ohio State with that survey, would you please fill it out and send it back? This information is part of the ACER grant, and it's going to be very valuable going forward. For the woodland owners, the first one has gone out. So you'll be getting a survey in the mail, and we'd appreciate you filling that out. So I think it's, this is part of our ACER grant. All these programs are part of our ACER grant, and we really appreciate being able to do that. And with that, I want to thank Aaron for a very, very enlightening program. I'm glad he's on our team. So, and I will be bugging you from now on in because
anytime
we'll make a maple producer out of you yet.
Hey, my wife will enjoy that.
You probably will.
Yeah.
We had one more raised hand.
Okay.
Arthur Kruger, if you want to unmute and talk, you may.
We can ask, I'll ask. So Les, I do see a few people in here who are West Virginia producers, some new ones who might not have been on that original producer survey mailing list. Is it too late? Are all the surveys out?
The third one went out. Yes. So that's the third survey, the third request. So they've been mailed out. We were a little disappointed in the second return on the second one, but I have an opportunity. It'll be in the mail again. So, and it's self-stamp envelope and everything else. So we encourage you to sign it up and produce it. Very valuable information for Ohio and West Virginia because USDA has made us NAs, not applicable. So my little dig against the USDA NAS system, they do a good job otherwise, but they did cut us out. So.
But for new folks who haven't gotten the survey, if you could get us your address, we'll make sure that Saeed, who's heading this up, gets that and get you a survey. So you could get it to Karen or Kate, and we'll make sure that happens. And we appreciate you wanting to help with that.
And anybody that didn't get one in Ohio that for some reason we overlooked, you can send that to ober.10@osu.edu, and I'll be glad to pass that on to Saeed, and we'll get that worked up and make sure that you get one. So just let me know.
Hi, folks. If you are, Karen just put it in the chat, but if you are a West Virginia producer, please email your address to syrup@future.edu. We see the one address in there, and we will take that down as well. But thank you, folks, for attending. I think we're going to wrap up since we're at our time limit here.
Looking forward to your next program on 3/16 with Art. So it's going to be very good.